Okay, let's look at line segments, rays, and midpoints, and how we use properties of them to solve problems. So first we are looking at a line segment. Now what makes this a segment as opposed to just a line is going to be the endpoint. So we have stopping points. Remember, a line is going to go on forever and ever in both directions, and that's why we have arrows on the end of it, whereas a line segment is going to have endpoints. So that is going to be our defining characteristic and how we know that we are looking at a segment. When we're naming a segment, we are going to use those two endpoints. So I'm going to use L and M, and we are going to put a segment on top of those two endpoints to identify this is in fact a segment. A ray is going to be essentially a line, however, it is only extending in one direction. So it is only going to be extending in one direction. And notice we have an endpoint, so we can see that endpoint, and then we can see that it is taking off in that one direction, whichever way that may be. So when we are naming a ray, again, we're going to use the points that we see on the ray. So in this case, G and H. And then we're going to put a little mini ray on top of those endpoints. And then lastly, we are going to be looking at midpoints. Now, what makes a midpoint special is that it is going to indicate equality. So we have A, B, and C. So if B is in the middle, it is our midpoint, that's what that stands for, then that means that on either side of that midpoint, we have equal segment lengths. So from A to B, notice that that is 3 units. And then we can also see that from B to C is 3 units as well. So that midpoint is telling us that we are dividing our segment into 2 equal parts. And now it is a point, hence the name. So that means if we're naming it, we're just naming it by whatever capital letter we are using, which in this case, our midpoint would be B. Okay, so we are first going to talk about our segment addition postulate, and that is that if A, B, and C are collinear points, which remember, collinear points means that they are on the same line, and B is between A and C, then what that means is if we take the distance from A to B, so if we take the length from A to B, and we add it to the distance or the length of B to C, then what that is going to give us is our entire segment length. So notice now I have covered the entire segment. So that is going to give us my whole segment length. Now, what does that look like when we see problems? If we look at number 3, notice that we are actually starting with, so this blue line is indicating that from C to A, so this whole segment is 12 units long. In our problem, we are given that from B to A, we have 3 units. And we are looking to determine what is the length from C to B. Well, if we know that our whole segment has to be 12 units long, and we know that 3 of those units are already accounted for, then that means that the last bit of our segment has to be 9 units long. And again, that's because if we add 9 plus 3, if we take each of these individual segments and we add them together, we get the whole thing, which is 12. All right, same thing for number 4. We are given that from Q to S, so our entire segment is 23 units long. And then we are also told that from Q to R is 11 units, and we want to know if Q to R is 11 units, then how long is RS if we know the entire segment has to be 23? So again, we can take our entire segment, we can subtract the part of the segment that we are given, and that's going to leave us with the other piece, which in this case would be 12. And we can always check ourselves, because if we add 11 plus 12, so if we take each individual piece of that segment, we do end up with the whole segment, which is 23. Now let's jump into some algebra. So again, we said with our segment addition postulate, we said that if we take each piece of our segment, so here we have DC, and we are given the length x plus 14, and we are also given an expression for C to B, and that expression, or that length of CB, is x plus 6. And then we also know that the whole segment is 16. So our whole segment is 16. Then we can set up our problem. If we take this red part of our segment and we add the green portion of our segment, then we are going to end up with our entire blue segment. So if we take each individual piece, the red part and the green part, we put them together, which means we add them together, we get the whole segment, which is the blue segment. So now we can fill in the expressions that we are given for each of these. So I know that my red segment is x plus 14. I know that my green segment is x plus 6. And I know that my whole segment, the blue portion, the whole thing, is 16. After we have set up our problem, now we are just combining like terms and solving our equation. So remember, there's an understood 1 in front of these x's, so we can add x plus x, and that is going to give us 2x. And I can also add 14 and 6, those are like terms. 14 plus 6 is going to give me a positive 20. And then I don't have anything to add as far as like terms on the right side, so I keep the equal 16 as it is. So again, now we just have a two-step equation. So remember, we're kind of wanting to do order of operations backwards, so we're going to start with addition or subtraction. In this case, because we are adding 20, we have to do the opposite to solve for x. So the opposite of positive is negative, or the opposite of addition is subtraction. And whatever we do on the left side of our equal sign, we have to do on the right. Now, make sure when we are solving these equations that we are paying attention to our signs. We bring down our 2x. 20 minus 20 is 0, so that's why those cancel out. And then we subtract 16 minus 20, and that gives us a negative 4. Now, our last step to get x by itself is we need to divide by the coefficient of x. So in this case, that is a 2. And again, whatever we do to the left side of our equation, we have to do to the right. So we also divide the right side by 2. So these are going to cancel out because they equal 1. So we have 1x equals negative 4 divided by 2 is negative 2. So that would be our final answer for the value of x. Okie doke, let's do it again. So number 6, I am given my segment from h to I, and I'm told that from h to I, I'm given the expression x minus 9. From I to j, the expression that describes that length is 2x minus 10. And then for my entire segment, I am told from h all the way to j is going to be 14 units. So again, if we take each individual piece, if I take my red piece plus my green piece, if I take those two pieces of the segment and put them together, then I've now gotten my entire segment. So after I've determined that, I'm going to fill this in. So my red is x minus 9 plus my green segment is 2x plus, oh sorry, not plus, minus 10. And that's going to equal the entire segment length, which I'm told is 14. So again, now I want to combine my like terms and solve for x. So again, I have 1x plus 2x, and that is going to give me 3x. And then negative 9 plus negative 10, again, watch your signs. Negative 9 plus negative 10 is going to give me negative 19, and that is still going to equal 14. Okay, again, when we have a two-step equation, we start with the addition or the subtraction first. In this case, we have subtraction, so we have to do the opposite of that, which is addition. We are subtracting 19, so the opposite would be to add 19. Whatever we do to the left side of our equal sign, we must do to the right. We have to keep everything balanced. All right, we didn't touch that 3x, so it is going to come down as is. Negative 19 plus 19 is 0. And then if we take 14 and we add 19, we are going to end up with 33. So again, my last step in solving my equation is going to be to divide by my coefficient of x, which in this case is a 3, so that these can cancel out. X is by itself. 33 divided by 3 is 11, and that would be the value of x. So that is our segment addition. We can take each piece of our segment, add them together, and set them equal to the whole thing. All right, midpoints. If we see the word midpoints, that is a major key word. Our ears need to perk up. So if we see midpoint, that is an important piece of information that we need to pay attention to. Okay, our midpoint is telling us that we have divided something into two equal parts. So if we are told that B is the midpoint of AC, if this is my midpoint, then that means that on either side of my midpoint, I should have two equal parts. So when I'm asked to find the measure of BC, I know that this side, BC, has to equal the other side, AB, so that means that BC is also 8. So that is what our midpoint tells us. It tells us that we have two equal parts. In number 8, we're told, again, that D is the midpoint in this problem. So that is telling me that I have two equal parts. On either side of this midpoint, I have two equal parts. So now notice, this problem, I want to know what is the measure of CE. So I want to know what is the measure from C all the way to E. Well, the information I'm given is that this side of my midpoint equals 6, which means, remember, that this side of my midpoint also has to equal 6. So if we take each segment of 6's and add them together, we get a total of 12 for the entire segment length. So CE would be 12 units long. Okay, just like before, we're going to add in a little bit of algebra. Now notice in number 9, we are not given a picture, but we can draw a picture. So we are told that P is going to be the midpoint. So if I have a segment and P is the midpoint of that segment, that means that P is going to be in the middle of my segment. And I'm told that it is the middle of X, Y. So that means that P is in between X and Y. The next piece of information I'm given is that from X to P, I use the expression 8x minus 2. So from X to P, I'm using the expression 8x minus 2. And then I'm also told that from P to Y, that segment length is used with the expression 12x minus 30. Now, we talked about midpoint being a keyword. And remember, it is a keyword because it is showing us that we have two equal parts. And now we have set up our equation. So what we want to solve for to find the value of x, make sure we're paying attention to what we're looking for. We are finding the value of x. So how we are going to solve this is by setting 8x minus 2 equal to 12x minus 30. Now, in this particular problem, we have x's on both sides of our equal sign. So we have to decide if we want to put the x on the left side of our equal sign or on the right. If we want to put x on the left side of our equal sign, that means that 12x, since it's on the right, needs to move over. And the way that we move things is by taking the opposite of them. So if 12x is positive, we have to do the opposite, which would be taking the negative. Now we do want to make sure we line up our x terms, and we're going to subtract. So 8 minus 12 is going to give me negative 4x. We did not touch negative 2, so it is going to come down as is. Our equal sign will also. 12 minus 12 is 0, so that cancels out. And then again, we did not do anything with our negative 30, so it is going to come down as well. Now, since I moved x to the left, my numbers or my constants need to move to the right. So that means that this negative 2 right here, it needs to move over here. And the way that we are going to move it is by using the opposite operation. So the opposite of a negative 2 or subtraction would be to add. So we are going to add 2, and whatever we do to the left, we have to do to the right. Now this time we didn't do anything with that negative 4x, so it will come down. Negative 2 plus 2 is 0. Bring down our equal sign. Negative 30 plus 2 is going to give me a negative, watch our signs, 28. And now, just like our two-step equations, our last step is going to be to divide by the coefficient of x, or what is attached to x. In this case, that is going to be negative 4. And remember, we have to do it to both sides. Stay balanced. So these will cancel out, and we will have x by itself, and that is going to equal negative 28 divided by negative 4 is going to give me a positive 7. So again, because I know that I am looking at a midpoint, that is telling me that I have two equal parts. So that midpoint is how I know that I need to set these two equations equal to each other. All right, last problem here. Okay, again, we are not given a picture, but we are going to draw one. So we are told that G is the midpoint. So I have some segment here. And G is in the middle of that segment, and it's indicating that I have two equal parts. It is in the middle of F and H, so we are told that it's the midpoint of FH. All right, the next piece of information I'm given is that from F to G is 14x plus 25. And then I'm also given that from G to H is 73 minus 2x. Now, if we went ahead and put our equal sign above our midpoint, then we have already set our problem up to solve for x. So, I can take 14x plus 25 and set it equal to, hang on, set it equal to 73 minus 2x. And again, we know we're setting this equal because we are told that we have a midpoint. Just like before, we are going to decide, because we do have an x on both sides of our equal sign, we have to decide if we want to move those x's to the left side of our equal sign or to the right. Again, I'm going to move mine to the left. You could move it to either side as long as you're making sure to take the opposite operation or the inverse operation. So if I'm moving my x's to the left side of my equal sign, that means that this negative 2x needs to move over here. So the opposite of that negative, or the opposite of subtraction, is going to be addition. So I need to add 2x. Remember, we're going to add it to the other x term. So now 14 plus 2 is going to give me 16x. I didn't do anything with my positive 25. Bring down our equal sign. Again, didn't do anything with 73. And then negative 2 plus 2 is going to give me 0. So that's how those cancel out. All right, my x's move to the left, so that means that my numbers, this plus 25, needs to move to the right. Again, we need to do the opposite of addition in this case, which is going to be subtraction. So we are going to subtract 25 from both sides of our equal sign. I'm going to bring down that 16x that I did not do anything with. 25 minus 25 is 0. Bring down my equal sign. And then 73 minus 25 is going to give me 48. So now my last step, I want to get x by itself, so that means 16 has got to go. I get rid of 16 by dividing both sides by that. So I end up with x equaling 3. So x equals 3. Now, if we jump back to our question, we are told to find FH. We just found x. We did not find FH. Notice FH is the entire segment. So we are actually looking for the entire length of our segment. How are we going to find that? Well, we are going to plug x back into one of our equations. I'm just going to go ahead and plug it back into this FG equation right here. So when I do that, I plug in 3, because now I know that x equals 3. Where this x was right here, now it's going to be a 3. And throw all of that into my calculator and get that the length of this segment is 67. Well, remember, G is a midpoint. So these segments have to be equal. So if the left side of the midpoint is 67, the right side is also 67. So if I want to know the entire segment length, I am going to add 67 plus 67. So we're going to add those together. And we are going to end up with our entire segment, which would equal 134. So that is going to be our final answer, because that answers the question to find FH. Anytime you see something other than solve for x, this is indicating that you're going to have to plug x back in. Okie doke, that was our midpoints and our segment addition.